Hey, it's Horner, and I want to take you through these examples. So, in our physics lab, Melanie rolls a 10-gram marble. So, we see that guy right there. And Melanie also says that she does that off a ramp, and it goes down, and it has a horizontal velocity of 1.2 meters per second. So, I know that the horizontal velocity, so Vx is equal to 1.2 meters per second, which is good. The ball falls in a cup and it is 0.51 meters away. So this is our distance in the x, or you could say it's your delta x. Either way you want to do it. They want to know how high is the table. So first thing we need to do is let's figure out the time that it takes for it to fall. So we want to know what in the world is the time to fall. So velocity in the x is equal to the delta x over the time. So we can now say time is equal to delta x over the velocity in the x. We'll plug our numbers in here. This is going to be 0.51. We're going to divide that by 1.2 meters per second. And when we do that, let's see what we get. 0.51 divided by 1.2, and we get 0.425. So this is equal to 0.425 seconds. So now we know how long it takes for it to fall, okay? But they want to know how high is the table. We know gravity is equal to 10 meters per second squared. We also know that our time to fall is equal to 0.425 seconds. We know that our original velocity in the y direction is equal to 0 meters per second. So let's use one of our kinematics equations. So to do that, let's actually do it over here. And we're going to say that the delta y, so that's the change in the position, is equal to the original velocity in the y times time plus 1/2 of gravity times time squared. So everybody says, well, is gravity positive or negative? The ball is moving in this direction, so we're going to make that positive. If that's positive, g can be positive. All right, here we go. We're going to do delta y is equal to, notice that this becomes 0, and that's equal to 1/2 of 10 times our time squared, which is 0.425 squared. So now we're going to take 5 times 0.425 squared, and we end up with a height of the table of 0.90 meters. And that's your final answer. So remember, on the AP test, you have to do more than this. You have to do all this stuff. You can't just put down an answer. You really want to make sure that you have an equation each time. You plug everything in, you get a number in a unit. Same thing over here, equation, plug everything in, number in a unit. So that would be worth 8 points on an exam. Bert is standing on a ladder picking apples in his grandfather's orchard. So here is our apple tree. Here is Bert. Ladder is here. Bert is standing on the ladder. And then what does Bert do? Bert takes this and he tosses an apple down into the basket. So let's figure out what these numbers are. So the basket sits on the ground 3 meters below. So I know that the distance here is 3 meters, and that's going to be my delta y. And I also know that there's a horizontal distance, and this is not to scale, of course, and this delta x is equal to 2 meters. It says how fast must Bert throw the apples in order for it to land in the basket. So when you do these, you always have to remember time is the bridge. Time is a bridge. And what does it bridge? B-R-I-D-G-E. It is the bridge between the delta y and the delta x. So if you have something in the y and you want to get to the x, you got to use time. If you want to go from the x to the y, you got to use time. So let's find time first. Which one of these two equations could we use to find time? Well, I know that I've got to find the velocity. So if I want to find the velocity, and the x direction, velocity in the x direction is equal to delta x over delta t. So I've got to find delta t over here in the y section. What did we say the equation was? It is delta y is equal to the original velocity times time. Remember, this is original velocity in the y times time, plus 1/2 of gravity times time squared. Again, down is positive for this one, so down is positive. And what we're going to do is we are going to plug in everything except for time. So delta y we know is 3 meters. That's equal to, remember, your velocity at the top in the y direction is 0. So this is 0 plus 1/2 of gravity is 5. And then we have time squared. So our answer here is time is equal to the square root of 3 over 5. And because it's really hard to plug this in over here, we actually need to do this math. So we're going to do the square root of 3 divided by 5, and that gives us point. So our time here is equal to 0.77 seconds. Now we can plug everything in. If I want the velocity is equal to delta x, which is 2 meters. I'm going to divide that by that 0.77 seconds that we used earlier. We got that earlier here. And now I can figure out the velocity divided by 0.77, and that gives me 2.6. Velocity in the x is equal to 2.6 meters per second. And that is my final answer. But remember, things are worth different amounts of points. So what we need to do here is we need to say, well, I know that this was a point for this equation, plugging things in, getting a number and an answer, equation, plugging in, getting a number and an answer. So that's another 8 points. So be really careful when you do these. Emmanuel Zucchini is the famous human cannonball. He was fired out of a cannon with a speed of 24 meters per second and an angle of 40. He landed 56.6 meters away, and they want to know how long was Zucchini in the air. Let's draw our triangle. So we know that this guy is launched at that angle, and that angle is 40 degrees. So there's my 40 degrees. And I know that my speed here in the 40-degree angle is 24 meters per second. I also know from where he was launched all the way over to where he landed was a delta x equal to 56.6 meters. Let's go through, and we need to figure out how long he was in the air. So I know that velocity in the x is equal to the change in the x divided by the change in time. And I see that I don't have velocity in the x. This is actually the velocity in both the x and the y combined. How would I get the velocity in the x? Well, let's draw a triangle. And I know that this side of the triangle is 40, that angle right there. This side is 24. I want to know what is the speed here, because remember this is 24 meters per second. Meters per second. So I want to find this side down on the bottom. I want to find Vx. So Vx is equal to, so this is our adjacent side. So I know I have to use cosine. So that's going to be 24 times the cosine of 40 degrees. Remember, this is the hypotenuse. This is my adjacent side. And so cosine of 40 is equal to Vx over 24. So Vx is equal to 24 times the cosine of 40. When I do that, 24 times the cosine of 40, as long as you're in degrees, gives me a speed in the x direction of 18.4 meters per second. Now I can figure out how long he was in the air. I'm going to rearrange my equation. The change in time is equal to the change in position over the velocity. Our change in position, we said, was 56.6 meters. And we're going to divide that by 18.4 meters per second. So 56.6 divided by 18.4 gives us 3.1 seconds. So he was in the air for a long time. Again, if you went through and wanted to figure out how do I grade this thing, we know that we have to have an equation, fill the equation in. Oops, so there's my equation. Fill it in, answer in unit, but there's more to this one. This one actually has another point for finding this equation. So this equation is 1 point, and then this vector component is also a point. I had to find this in order to plug it in over here. So it's something that's very important. So 1, 2, 3, 4, 5, 6 is what that one is worth. For our next example problem, this is the last of the example problems, we have Emmanuel, oh no, this is Robbie Knievel, sorry. He jumped over the Grand Canyon Gorge. So we know that the gorge, which is just really a valley or a distance between 2 points, between two cliffs, and that distance is 69.5 meters. It says that he was in the air for a total time of 3.66 seconds. They don't really tell us anything else. They want to know what height from a starting point did this daredevil achieve. So we want to know when that person was up here at the top, how high were they? So we want to know what is that delta y at the very top. So here we go. In order to do this, what we need to do is start with our equation. So let's think about, this is a projectile. We know that it goes up, and we also know it's going to the right. In order to use this 69.5 is the total distance across. We only want half that distance. So 69.5 divided by 2 is going to give us a distance that we want. So our delta x here is equal to 34.75, and that's meters. How long did it take to go that? So that's our delta t, and that's equal to 3.66 divided by 2. So we want 3.66 divided by 2 is 1.83, and that is the time it takes to go that distance. So this is 1.83 seconds. So now we can find out what is our velocity in the x direction. So we're going to do delta x over delta t, and that is 34.75 divided by 1.83. So 34.75 divided by 1.83, that gives us 18.999, or we can go ahead and do, let's round this to 19 meters per second. So that is how fast he is going from left to right. They want us to find out how high does he go. So the same time going up is what it's going to take to go back down. And if I want to find this highest height, I just need to know how much time does it take for him to go up there. And remember, it took 1.83 seconds. So that's our time. We already figured that out. What is the equation for delta y again? So delta y is equal to the original speed in the y times time plus 1/2 of gravity times time squared. We know that they're going 19 meters per second, but be careful because that is the velocity in the x, not in the y. We want the velocity in the y. Well, the velocity in the y down here, we're not really sure what that is because we don't have an angle right here. But we do know the velocity in the y up top is equal to 0, because when you go up, you slow down, and then when you go back down, you speed up. So that's super important. If I know I want to find delta y, and that's equal to 0 times my time, plus 1/2 of 10, times my time squared. And remember, our time is 1.83, so let's go ahead and plug that in, times 1.83 squared. So this is really going to become a left parentheses. I can find out how high he went, and I don't have to use this 19 at all. So everything that we did down here, we really don't need. So I'm just going to cross this off, and we're going to leave it at delta y. So this is 5 times 1.83, and this person went 9.15 meters in height. And that is measured from here up to here, okay? So that is because he started at the same level that he ended at. And that is the end of the just the examples.